Every day, our modern world relies on satellites orbiting far above our heads. They help us navigate with GPS, forecast the weather, beam television and internet signals, and even monitor global environmental changes. But just like everything else, humans build. Satellites don't last forever. So, what happens when they die? Do they just float around endlessly in space? Do they burn up in the atmosphere? Or is there actually a place, a so-called space graveyard, where they're sent to rest? The answer is a bit of all of the above, and the truth is both fascinating and slightly alarming. Let's rewind for a moment. When a satellite is launched into space, it's designed for a specific mission and lifespan. Some might only last a few years, while others are built to operate for decades. But eventually, due to fuel depletion, mechanical failure, or simple obsolescence, every satellite reaches the end of its functional life. And that's when things get complicated. You can't just call a tow truck an orbit. Once a satellite is dead, it becomes space junk. And with tens of thousands of satellites launched since the dawn of the space age, the question of where they go after death is more relevant now than ever. For satellites orbiting relatively close to Earth, what's called low Earth orbit, or LEO, they have a natural solution. Earth's atmosphere doesn't just stop suddenly. It gradually thins out. Even at altitudes of a few hundred kilometers, there's still a tiny amount of atmospheric drag. This drag slowly pulls satellites downward. Over time, sometimes years, sometimes decades, they re-enter Earth's atmosphere. And when they do, most of them burn up completely due to the intense heat of re-entry, disintegrating into harmless fragments that never reach the ground. That is the fate of many old satellites in low orbits. A fiery plunge into Earth's sky, invisible to us, but dramatic in its own way. But not all satellites orbit that low. Many operate in higher regions like medium Earth orbit, or even geostationary orbit, where drag from the atmosphere is practically non-existent. These satellites won't come down on their own, and sending a spacecraft to retrieve them is still enormously expensive and technically challenging. So instead, engineers developed another solution: the graveyard orbit. That's right, there is a literal space graveyard, also known as a disposal orbit. This is a special zone located a few hundred kilometers above the geostationary belt. When a satellite in geostationary orbit reaches the end of its life, it's programmed to use its remaining fuel to move up into this quieter orbital zone. Up there, the satellite is far from operational orbits, minimizing the risk of it colliding with active satellites. Once it's there, it's essentially abandoned. It will float in silence, indefinitely, a ghost of its former self, circling Earth long after its mission is ended. But here's where it gets spooky. As of now, there are more than 3,000 defunct satellites in orbit. Add to that thousands of spent rocket stages, bits of shrapnel from past collisions, and fragments from anti-satellite weapon tests, and you have an ever-growing cloud of debris, what scientists ominously call orbital debris. And the problem is getting worse. Even tiny objects in orbit travel at speeds of over 17,000 miles per hour. At those speeds, a paint fleck can crack a window, a bolt can puncture a spacecraft, and a collision between large objects can create a deadly chain reaction. This is known as the Kessler syndrome, a theoretical scenario where space becomes so littered with debris that one collision leads to another. And eventually, low Earth orbit becomes too hazardous to use. NASA, the European Space Agency, and private companies are all well aware of this looming threat. That's why modern satellite design includes end-of-life planning. For example, when satellites in low Earth orbit are decommissioned, they often guided into what is called a controlled deorbita maneuver that ensures they re-enter Earth's atmosphere safely at a predetermined location, usually over the South Pacific Ocean. This remote spot, known as the spacecraft cemetery, is the final resting place for hundreds of satellites and even space stations. The most famous resident, the Russian space station Mir, which was deliberately deorbited in 2001 and crashed into the Pacific after 15 years of service. But while some satellites are carefully removed, many older ones and even some current missions don't have a retirement plan. Some run out of fuel before they can be guided away. Others malfunction suddenly and go silent, drifting uncontrolled through space. These derelict satellites can't communicate, can't maneuver, and can't avoid collisions. They are, quite literally, ticking time bombs in orbit. That's why the race is on to develop new technologies for cleaning up space. One idea is to send robotic spacecraft to intercept dead satellites and push them into the atmosphere. Another uses nets, harpoons, or tethers to capture junk and drag it down. Still, others propose using lasers to gently nudge debris into lower orbits where it will burn up faster. The European Space Agency even has a mission called Clear Space set to launch in the next few years, which will attempt to remove a single piece of space debris using a claw-like device. It's just one small step, but it could pave the way for more advanced cleanup missions in the future. Private companies are also stepping up, with the explosion of satellite which plans to launch tens of thousands of small satellites there. It's a growing responsibility to ensure these satellites stand to become future hazards. Starlink satellites, for instance, are designed to deorbit within 5 years of failure, thanks to onboard propulsion and low operational altitudes. But with so many objects being launched every year, even a small failure rate can mean hundreds of new pieces of space junk annually. So, what does the future hold for dead satellites? Ideally, smarter designs, better orbital traffic management, and international cooperation will help reduce the problem. But right now, we're still playing catch-up. The vast emptiness of space may seem infinite, but the orbits we use are finite and increasingly crowded. The sky above us is becoming a cosmic junkyard, and the longer we delay addressing it, the more dangerous it becomes for the future of space exploration. And yet, there's something poetic about these derelict machines. They were once the cutting edge of technology, built with precision and purpose, launched on roaring rockets into the unknown. They orbiate Earths in silence, serving humanity's needs without fail. And now, they drift alone, some burning up in a final blaze of light, others forever circling in darkness, relics of a civilization that dared to reach for the stars. So the next time you glance up at the night sky, remember, among the stars and planets, there are also tombstones. Invisible, yes, but very real. Each one a piece of history, a chapter in the story of space, a silent witness to the ambitions of humankind, and a reminder that even in the cold vacuum of space, nothing lasts forever.